Hi, lovely humans. We're back for more integration by parts. Okay, so we have sometimes integration by parts can take a really long time because there's just a lot of steps. Um, so let's go ahead and do this problem using integration by parts, and then I'm going to show you a different method to complete integration by parts that I think you're going to like. Okay, so first, we're just going to do it the old-fashioned way. We're going to find the integral of x squared sine of 4x dx, and I am going to assign x squared as u and the sine of 4x dx as dv. So the derivative of u is equal to 2x dx, and the antiderivative of dv would be the integral of sine is negative cosine of 4x, but remember that I'm just going to do it under here. The sine of, I'm going to make 4x equal to w. And then, so if w is equal to 4x, then dw is equal to 4 dx. So dx is equal to d, let's pause this since, all right, and we continue. So dx is equal to dw over 4. So when I replace the dx, I get dw over 4. So the integral of sine w would be negative cosine of w times 1/4. Okay, and w is 4x. So basically, plus c. Basically, what we're doing is also multiplying by or dividing by the derivative of the inside. Okay, so I get negative 1/4 times the cosine of 4x. All right, so I'm just going to work going downward. So I end up with the, stop moving, the integral of x squared sine of 4x dx is equal to u times v. So x squared times negative 1/4 times the cosine of 4x minus the integral of negative 1/4 times the cosine of 4x. I didn't put v here. Times the du, which is 2x dx. Okay, that can be rewritten. Let's do that. So I get the integral of x squared times the sine of 4x dx is equal to negative 1/4 x squared times the cosine of 4x. And then the two negatives makes a positive times the integral of 2 times 1/4 is 1/2. So 1/2 x times the cosine of 4x dx. All right, it definitely looks like we need to take the integral of 1/2 x cosine 4x, and this looks like a second integration by parts to me because we have two, our integral is composed of a product, two pieces multiplied together. All right, so I'm going to have u is equal to 1/2 x, and dv is equal to the cosine of 4x dx. All right, the antiderivative of cosine is sine, so it's going to be sine of 4x, and then I have to divide by the derivative of the inside, so 1/4 sine x, okay? And du is equal to 1/2 dx. And I'm going to make this u2 and v2, just so I don't get confused. Okay, so this ends up being the integral of 1/2 x times the cosine of 4x dx is equal to 1/2 u times v, 1/2 x, times 1/4 sine of 4x minus the integral of v, which is 1/4 sine x, sine of 4x, sorry, times du, which is 1/2 dx. So I think I can go ahead and simplify that. So 1/2, the integral of 1/2 x cosine of 4x dx is equal to 1/2 times 1/4 gives me 1/8 x cosine, oops, that's sine of 4x, right? Yeah, okay. Minus the integral of 1/8 sine of 4x dx. All right, last step to get this one simplified, and then we can replace that back into the green. 1/8 x sine of 4x minus, okay, the integral of 1/8 sine 4x would be negative cosine, so negative cosine, which is going to give me a positive, because a negative times a negative is going to give me a positive cosine of 4x, and then don't forget to divide the 1/8 by the 4, giving me 1/32 plus c. Okay, over here you can do a u substitution if you want, but the quick way for me to do this is just to divide by the inside function. Okay, the derivative of the inside function. All right, so now I know that this integral here, 1/2 x cosine of 4x dx, is the same as 1/8 x sine of 4x plus 1/32 cosine 4x plus c. So let's rewrite all of this business. I'm going to go back and look at this right here. Okay, and I'm going to say that the integral of x squared sine of 4x dx is equal to negative 1/4x squared times the cosine of 4x. Okay, now we need to move on and look at the integral for 1/2 cosine 4x dx, which is 1/8 x sine of 4x plus 1/32 of cosine of 4x plus c. And I end up with my real answer in purple right here. Whew, we done. Okay, so that was using integration by parts twice, okay? Now we're gonna use something called the tabular method. The tabular method is just a way for us to organize all of our derivatives and our antiderivatives and then put together our answer pretty quickly, okay? So this is how we set it up. We do signs like S-I-G-N-S. We always start with a positive, switch to a negative, and then a positive, and then we switch to a negative, okay? And then so on and so forth. And then we look at what our u is and what our dv is. Okay, here we're going to be taking the derivative, and here we're going to be taking the antiderivative, or the integral. Okay, so whatever your u is, I decided that u is going to be x squared, because when I can take the derivative and I'm going to end up with a derivative of 0 at some point. Okay, the derivative, and then what I'm going to set up as the antiderivative, or the dv part, is the sine of 4x. Okay, and then we start with u, and we take the derivative of x squared, which is 2x. Then the derivative of 2x, which is 2. And then the derivative of 2, which is 0. And that's where I get to stop, okay? The antiderivative of sine of 4x would be negative cosine of 4x, and then divided by the derivative of the inside. So negative 1/4 cosine 4x. And then we get the antiderivative of cosine is sine, so it's still going to be negative because there was already a negative. So sine of 4x, and then we have to multiply the 1/4 by 1/4, which gives me 1/16. Okay. Then we take the antiderivative one more time. So once the antiderivative of sine is negative cosine. So a negative times a negative is going to give me a positive cosine of 4x. And then remember, we take the 1/16 and divide it by 4, giving me 1/64. Okay, so how we set this up is I'm going to say the antiderivative of x squared sine of 4x dx is equal to, and all you do is you start in the left corner with your positive sign and you move to your x squared and then down to your the first integral. Okay, so I do positive x squared times negative 1/4, well, yeah, times negative 1/4 cosine of 4x. Okay, next is a minus 2x times negative 1/16 sine of 4x. And then lastly, we end up with positive 2 times 1/64 cosine of 4x. And then I am going to simplify this to give me the integral of x squared sine 4x dx is equal to negative 1/4 x squared cosine of 4x plus, because it's a negative times a negative, and 2x times 1/16 gives me 1/8x times the sine of 4x plus 2. Oh, wait a second. I messed up here. No, I'm good. Okay. So 2 times, I messed up on my paper. Okay, 2 times 1/64 is 1/32 times the cosine of 4x plus c. Ooh, I forgot my plus c. And I'm going to look, do these two purple equations match each other? They do. And so it doesn't matter if you use integration by parts twice or if you use the tabular method to apply integration by parts, you're going to get the same thing. I personally like the tabular method because it's really fast and it's a lot easier for me to organize and it's a lot less writing. Okay, so let's use another one. We're going to find the definite integral, and I can see that when I set up my u, the derivative of u would be 2x, so I'm probably going to have to take the derivative again. So I am going to set this up using the tabular method. We start with a plus, a minus, and then we'll see what happens from there. U is equal to x squared minus 1, and dv is going to be equal to e to the x dx, so e to the x. All right, so I'm going to take the derivative of x squared minus 1, which is 2x. Take the derivative of that again, which is 2, again, which is 0. So I need to add some signs over here. And then the antiderivative of e to the x is e to the x. Okay, and now I can set this up using my chart. So I have x squared minus 1 times e to the x, and then the next term would be minus 2x times e to the x. My third term would be plus 2 times e to the x, and we're going to evaluate this from 0 to 1, since this is a definite integral. Okay, so now it's time to just substitute in the values, and I get, let's substitute in the 1. So I have 1 squared minus 1 is 0, times e to the x would be 0, or e to the 1 would be, well, times 0 would still be 0, so I'll just put times e to the 1, minus 2 times 1 is 2, e to the 1, plus 2, e to the 1, minus, let's plug in 0, so 0 squared minus 1 is negative 1, times e to the 0, negative, minus 2 times 0, e to the 0, plus 2 e to the 0. Some of these things you could evaluate in your head. If you did that, that's fine. Just write, you could probably skip this step and just write the next step, okay? So I have 0, and then 2e to the 1 minus 2e to the 1 is 0, so that's just 0. And then I'm going to distribute this negative, so I end up with negative positive 1, because e to the 0 is 1, so plus 1, and then this is going to give me a 0. 2e to the 0 would be minus 2 because of the negative on the outside. So that gives me evaluated at to negative 1. Okay, the last type of integration by parts is when we have non-terminating factors. So what's going to happen here is, well, let's set up our, I'm going to set up this using tabular method. So we have the signs plus, minus, and I'm going to set up sine of x as u, and dv is equal to e to the x. So, and when I take the derivative of sine x, I get cosine of x. When I take the derivative of cosine, I get negative sine. When I get the derivative of negative sine, it's negative cosine of x. And the antiderivative would always be e to the x. And I can see that this is never going to stop. So what if I switch my u and my dv? But, okay, so if I switch these and make u e to the x and dv sine x, I see I'm going to end up with the same problem. I get e to the x, I get e to the x, I get e to the x. The antiderivative of sine is negative cosine x, then negative sine x, then cosine x, then blah, blah, blah. It keeps going on and on forever. So tabular method's not going to work because we're just going to have to keep expanding out our expression by adding more and more terms. So sometimes we can get a like term with our integral. I'll show you what I mean. So we're going to make u equal to the sine of x and dv equal to e to the x dx. Okay, let's take the antiderivative. I get e to the x, and du is going to equal cosine of x dx. So I end up with the integral of e to the x sine of x dx is equal to u times v, which is, I'm going to do v times u, so e to the x sine x minus the integral of e to the x times cosine dx, so you do, okay? And I'm looking, do these two integrals match? No, but maybe I'll take the integration by parts again for the integral of e to the x cosine x dx, and I'm going to kind of set it up the same. u2 is equal to the trig function cosine x, and dv2 is going to equal e to the x dx. The antiderivative of e to the x is e to the x. And the derivative of cosine would be negative sine x dx. Okay. So next up is to write out, I'm just going to write out what the integral of e to the x times cosine of x dx is, written using our integration by parts. So u times v, so e to the x times the cosine of x minus the integral of v, e to the x, times negative sine x dx. So written out a little nicer, I get e to the x times the cosine of x plus the integral of e to the x times sine x dx. And I notice right now that this integral, when I use my integration by parts, that the integral of e to the x sine of x dx shows up in my integration by parts. And that was the original integral that we were trying to evaluate. So let's combine these. I'm going to write the integral of e to the x sine x dx is equal to e to the x sine x minus, let's see, e to the x, oh wait, all of this is being subtracted. So minus e to the x cosine of x plus the integral of e to the x sine of x dx. I will distribute the negative, giving me the integral of e to the x sine of x dx is equal to e to the x sine x minus e to the x times the cosine of x minus the integral of e to the x sine x dx. Okay, we're going to get like terms combined, so I'm going to add the integral of e to the x sine x dx to both sides. And that's going to cancel, giving me 2 times the integral of e to the x sine x dx is equal to e to the x sine x minus e to the x cosine of x. And the only thing I have to do next is just isolate the integral, our original integral. So I'm going to divide both sides by 2. And I end up with the integral of e to the x sine x dx is equal to 1/2 e to the x sine x minus 1/2 e to the x cosine of x. And that's just some tricky business to integrate our original function. Whoa. Okay, anyway, I will see you later. Bye.